Hello, in this video we're going to talk about deep learning. We're going to do a special test for running a convolutional neural network. So we will cover the computational speed comparison between running it on the CPU versus on the GPU. So we know that if you have a large dataset and a decent GPU, so running a deep learning algorithm such as CNN will be much faster than running it on a CPU. But is this also true for a small dataset? We will find it out in this video. First, I'd like to introduce the data that I use for this test. So this is a crop yield dataset which has only 70 variables. So it's not really a large dataset compared with those images. And for this test, we're going to use Spider for the CPU test and Google Colab for the GPU test. So just to introduce the specifications for the CPU and GPU, the CPU I use is Intel Xeon Silver 4215 CPU. It has 8 physical cores and 16 logical cores. And the main frequency is 2.5 GHz. The GPU I use is from Google Colab. It is NVIDIA K80 or T4. You cannot select which model, but it's usually randomly assigned. Okay, so which one's faster? Let's get started. So just to touch briefly on the settings, the left hand side is the Spider, which is for the CPU test, and the right hand side is Google Colab, which is for the GPU test. So first we start from small hidden layer numbers. Let's try 80, 40, 20, 10, and 1. So we set these hidden layer numbers on both sides and start. As you can see, the left hand side is about 1 millisecond per step and the right hand side is about 5 milliseconds per step, which means running this CNN for this dataset on CPU is actually about 5 times faster than running it on the GPU. Quite a surprise, right? Don't worry, let's increase the hidden layer number. Let's try 800, 400, 200, 100, and 1. Start. Alright, this time the left hand side has 5 milliseconds per step and the right hand side is also 5 milliseconds per step, which means running it on CPU and GPU are about the similar speed. Now, what about even larger hidden layer numbers? Let's try double the numbers. Okay, so let's increase the number to 1600, 800, 400, 200 on the left hand side, and also the same settings on the GPU hand side. Try it one more time. Here we go. So as we can see, the right hand side, GPU side, requires 7 milliseconds per step. However, the left hand side, CPU side, requires about 13 milliseconds per step, which means running it on the GPU is about twice faster as compared with the CPU. That's quite a reverse, right? Okay, let's further increase the hidden layer number. Now let's try 3200. Okay, we could also just try the first line code, but just to be consistent, so we increase all the other hidden layer numbers as well. Okay, start. Okay, CPU side start to run first. That makes sense because it just get the data from the RAM, which is faster. Okay, now the GPU side already gets the result, but the left hand side is still running the first epoch. Okay, so GPU requires 9 milliseconds per step. However, CPU requires 40 milliseconds per step. Okay, that is about 4 to 5 times of the GPU running time. Quite impressive, right? That means running this on GPU is about 4 to 5 times faster than running it on the CPU. Okay, now let's further increase the hidden layer numbers. Let's try to double the number. Let it be 6400, 3200, 1600, and 800. And we change the numbers on the right hand side as well. Will the GPU be even faster as compared with the CPU? We run into an error on the right hand side, but as we can see, the left hand side has already started. So let's rerun the code on the right hand side. Run each code block and see if it works. Okay, right hand side started. 6, 5, 4, 3, 2, 1. 23 milliseconds per step. Let's look at the left hand side. We know that it started earlier, but it's still doing the computation. Quite a difference, right? Okay, the right hand side we get the second epoch down, while the left hand side is still doing the first epoch. Right hand side, third epoch down. Let's look at the left hand side. Okay, 137 milliseconds per step. That's almost 6 or 7 times slower than the GPU. Okay, quite a difference, right? Alright, let's stop this. And just to check that we're running on GPU, and you can also change it to TPU, Tensor Processing Unit, if you like. But this is out of the scope of the video. Alright, so from this video we know that running on GPU, it really depends on how large your hidden layer is. Okay, we haven't changed the epoch number here yet, but it should also be a factor. Okay, thanks for watching, and I hope this video is helpful. I'll see you in my next video.